Okay. So guys, thank you for choosing 3D modeling and Blender in 3D modeling and animation in Blender. I'll be presenting it today. My name is Ahmed Hamid. It is an anagram. My parents were lazy when they decided to name me. If you have any questions, guys, please don't hesitate to ask during the actual session. But the way I'm going to be presenting this today is how I would present it in a classroom. I'm not a big sort of PowerPoint type person. I like to just show it, demonstrate it, and then get the kids to sort of follow along as I go along. So the project I've got here today is one of ones I've created. So by all means, if you feel like you want to use it, you just go ahead and use it. I'm actually screen recording this session as well. It's so hopefully that will be available for you guys as well. But this is exactly how I do it in class. I will present, I would screen record my lesson, and at the end of the lesson, I would upload it to Google Classroom for those who might have, fell behind. And, because we're also time poor anyway, and the students can go back later on and just watch the video. So this little happy little fellow is what we're going to create today. It's a modified version of one I created a while ago. So it's a tiny little animation of a little piggy in a grassy field. Now this is just the basic style animation. When I say basic, it's more like a stylized style animation. But I've modified it and changed it from what I had in the stage 5 because we're about to start something new at our school. We're going to be doing an accelerated industrial tech multimedia class. So I've created this hybrid project where it's a mix between a stage 6 level and a stage 5. Somewhere in the middle is what I've created here. So this is stage 6, stage 5 level, that kind of helps. It's an easy enough project for most to wrap their head around. Now, most of you have gone online and done the YouTube tutorials. I'm sure you've looked them all up. We've all seen the Blender Guru and all of that jazzy stuff. One of my favorite ones is Southern Shorty. He has amazing, simple enough tutorials to follow along. But the problem is with those guys, they're industry level animators. So a lot of times they're going to use terminologies straight out of the gate, assuming that you know what they're talking to people that understand it. All right. So what I've done is created a project really tailored for teaching. Simple enough that can be delivered in a lesson. When I say a lesson, it's over a period of lessons. Depends on how many hours you have in a classroom in your school, but in my school it's 1 hour. So this is broken up into chunks so it can be delivered over a period of time. Roughly, depending on your student's skill set, it can take up to, we can say maybe as short as an hour and as long as 15 hours. It really does depend on the student's skills and their abilities. But the end result is you get to create something that is easily recognizable, but easy enough to make that anyone should be able to make it. The tools that you guys are going to be seeing today are majority of the time what students will use in all the animation components. One of the most difficult things there is actually physically animating the character. One of the lessons I like to deliver is on anatomy and movements. So things that you would normally not think about in the syllabus because it really doesn't talk about it, just says animation. But how to actually deliver and how to make something animate, following the principles of the 12 principles of animation, that's one thing. But even then, wrapping your head around moving an object in 3 dimensions, but reality is you're actually moving it in 2 dimensions to represent it in 3 dimensions. So it's like this weird kind of crossover. And just to get a movement that's somewhat natural, this is why I like stylized characters, because a stylized one gives you kind of an idea of it's on the fence whether it should look like that or not. So that's why these are the funner ones to create. More realistic things like an actual human or any sort of real sort of characters, that's the more complex stuff. That's the kind of stuff I'd leave to a stage 6 level. But at a stage 5 level, this little piggy or any other little creature that they want to create is very straightforward. So you can create absolutely anything for simple geometry. This little pig is actually made up of a cube. Its original was a cube. Well, they're also known as a round cube or a, I suppose round cube basically. But there it is. We're using a few different types. We're having a particle simulation, which makes the grass do that. We have advanced texturing. If I zoom right into my piggy, you'll see that his skin has actually got tiny pores and tiny little imperfections. These are the sense of realism that you can put into it. So this is what I'm saying, it's a hybrid one, because I am going to run an accelerated industrial tech multi-class. I wanted to leave take some of my stage 6 stuff and my stage 5 and slam it together and create something new. But there is the old one that's on YouTube. If you want to see it, it's my YouTube channel that it's on there. It's called Tech for Schools. The old stage 5 one is on there, but this is, like I said, it's the hybrid one. More realistic skin textures that you generally can reuse for other things, so humans and whatnot, hairless creatures, I would say. But it works perfectly for a pig. Things you're going to be looking at using today, hopefully you have time, is using a Bezier curve to generate a curved surface, so the tail itself isn't actually sculpted, it is generated from a curve. Using round cubes, using things called remeshing. We might use a remesh, it depends on how complex your mesh ends up becoming. There is the Boolean, where we're merging two geometries together to generate brand new geometry, and then your general spheres, and my personal favorite, the meta rigs. Okay, so this character has advanced rig system. So a lot of times you'll notice that people would just use the basic armature and generate animations from the armature, which by all means you can, but that's actually a time-consuming process. It's easier enough to make a really random skeleton, but harder to animate because you have to move individual bones and keyframe the individual bones. What we're going to be using is an advanced rig system, what you generally use for industry. This advanced rig system is what you see here, all these squiggly little lines. If I go into its pose mode by selecting the actual rig, going in the pose, you'll see that I'll turn off the meta rig, which is the bone structure. This right here is the control bones. So if I was to choose anything like, or I don't know, let's say his rotating shoulder, chest area, double click R on the keyboard, you'll see that it's not just his body that moves, his legs will move with the body as well. So it gives you more of a natural movement. So when you're keyframing this, you're keyframing one bone rig that will generate others. Same as the rear torso control bone, which is this one here. If I double click R on the keyboard, you can see that I have full control over my character. And you'll notice that the little bones on the inside where those little weird red arrows are, they're generating the movements for you. And so why don't you keyframe it? I just have to keyframe that one single bone. Before, in the other one that I used to run, is just using this, the basic armature, and then keyframing the armature. There's also something else we're going to be looking at today, and that is shape keys. Now, shape keys are my personal favorite little things. So you notice his little ears that are wiggling backwards and forth, and his nose are kind of shuffling from side to side. So his nose is using the bone control, but his ears don't have any bone structures at all. So we all wanted to generate more of like a floppy type system. You can do it two ways. You can create so those were in stage 6, I'll probably leave it for stage 6 one. You can set up a cloth simulation just on the ears. So wherever the bone moves, wherever the pig moves, the ears will just sort of follow and just they can, flop around. Or you can physically keyframe that movement yourself by using shape keys. Now, shape keys are very straightforward. If I was to click on, come out of my pose mode for a second, go into object mode, go into here. In my little actual mesh, there are the controllers. So down here in what they call the object data properties, shape keys. So the base mesh is what the pig originally looked like when it was sculpted. Left ear, right ear. And I literally move a slider backwards and forth, and that will just control just the ear. Now you can do that to any part of the pig. So for example, if you wanted to give it an expression, so once again, I would leave that more for the stage 6 level where it might talk. There's two ways you can do it. You can use a very advanced rig system to control the bones, but a character like this, that's kind of like overkill. So simply having a cutout and then generating a shape key and then sculpting the positions of the mouth. So I think there's that one and that one, and everything else just happens in between. So you move this, it will just generate the in-between frames for you. Okay, does that kind of make sense? So shape keys are one thing. Shape keys are great for definitely expression. So if a character is smiling, putting in that wrinkle that might appear, putting in a dimple, that's how you generate them. So it's kind of pointless adding a bone structure just to generate a dimple, but if your character has a dimple, you can just put it in as a shape key and it can shape it in and out as well. So this is what animators do in the industry to sort of make it as efficient as possible and less demanding on hardware. And that's kind of the big sort of takeaway in today's thing, guys, is the demand on your computer. The more advanced the rig systems are going to be, the more advanced textures you end up using, the more lag you're going to find. And this is where students will end up getting frustrated because they see that it moves pretty seamlessly, but you know, I had to spend $4,000 on a computer to make sure it can run as seamless as possible. So giving an understanding of where the hardware limitations meets the software. A lot of times when the kids get to that point where they begin to understand how to do everything, they want to do more, and then eventually they'll hit the bottleneck of what the computer is actually capable of generating. So just keep that in mind, that a lot of times they won't get marked down if they can't do an advanced skin texture or anything along those that, or even today. I don't know if none of you can notice it, but as the light penetrates the piggy's skin, it's bouncing around in the internal surface. That's called the subsurface scattering. So as the light is penetrating, it's actually moving around the body and coming out in a certain distance to give you more of a natural skin texture. The more subsurface scattering that you put in it, so like transparencies or slight frosted glass or anything like that, that's when the computer really will start to begin to struggle. So just sort of keep that in mind, that you can kind of overshoot it and end up making the computer struggle to the point where it can't actually do anything. Just to give you an idea of how the shading looks, so this is what the skin actually looks like. What we're seeing here are the shader nodes that generate the skin. Each one of these have a certain properties that gives you what you see there. From the bump map, what you see down here, which generates all the imperfections in the skin, to the coloring, to the in-between coloring as well, into the subsurface scattering and the surface scattering of the light. Okay, and that's really where the big kicker is with all this stuff. I haven't got any sort of fancy light systems. I'm just using a basic single point light to light this environment, but as soon as I start putting more advanced light systems in, that's when things get even more slower. Okay, everything has a limit to what you can do. To get that super hyper realistic look, you need some real heavy horsepower to be able to push all those pixels and all that demanding information for the computer. But yeah, so look, particle systems are really relatively easy to do. There's two ways you can do them. You can go with a simulated particle system, meaning that the grass will just interact with anything around it depending if something disturbs it. So for example, you put in turbulence or wind, it will just interact with that. You can have dynamic particle systems. So if my pig was to actually walk through this grassy field, it should be able to part the grass. If my pig's got a collision on its surface, meaning that it's a hard-bodied surface that's going to interact with it, that should be able to disperse the particles. As soon as you start doing stuff like that, once again, you'll start slowing down the machine because that's computation. All right, that's your computer's trying to work it out from then on. But the way I've done the grass here is a mixture of keyframe animation and simulation. So I'm mixing the two together. I haven't put in a collision for the sake of just the continuity and making it easy enough so that everybody can do it. But in this actual thing, it has a wind emitter. So if I come right out, you see that thing that's oscillating from right to left? That is just wind. And so I just keyframe the actual emitter itself. So it generates the wind in the direction of the wind, and then all I do is shake it from left to right, which makes the grass move from left to right. But if you look very closely, if I go into the Z-axis, you'll notice that the actual grass is twitching as well. So what's happening here, there's a turbulence added to it. So the turbulence is what I call freeform animation. So this button right here, if I click on this, it would automatically keyframe. So you can move the timeline and it will just generate a keyframe for you, and then you move your character, off you go, which is great for speeding up the animation process Downside is you could accidentally put too many keyframes in for certain things. But because this is grass and wind does not move, or it has its own properties and own physics, and I wanted to make it as natural as possible, that thing that's moving around there, that dot, is the turbulence. That is actually my hand. So all I've done was click on this, press play, and then move the emitter around on the z-axis, just free-handing it from side to side, kind of swaying like it was the wind. And the end result is you get something that looks more natural because it's actually mimicking a real-life hand. Because it's recording. It literally recorded my hand gestures. Does that make kind of sense? So there's the kind of freeform animation that you're going to do. So we're going to looking at freeform animation, meaning like auto keyframing. We're going to look at physical keyframing, and definitely for actual animation, you might want to just do physical keyframing. And yeah, some basic particles and lights and skin textures. The one that's going to probably take a bit of the longest is the rigging system. Making the pig is one thing because that will take up time, because it's up to you and how you want to stylize it. But the rig is relatively easy to actually use. I'll quickly show you where it is. If you go everything that's special in Blender, a lot of it's actually pretty much hidden. So if you go to Edit and Preferences, and there's a nice little tab that says Add-ons. In here are everything that Blender has that you'd never see. Unless you really need it, they generally have it turned off. If one of the most important ones, which most people have turned off, is Rigify. So R-E-G, and you'll see it, that is Rigify. So rigging and Rigify. It gives you meta rigs. Now what is a meta rig? If I was to go Shift A into my environment, go down to my armature. Once upon a time, if I was to just make a normal rig system, I would just use a single bone, then build my own skeleton. You'll see there's a human meta rig. If I click on that, it gives you a full skeleton, all right, with a full face bone structure, ready to go. And then you literally put that into your system, into your model, and make sure it rigs properly. But the good thing about meta rigs is generates right here in the actual bone properties, so in this little running dude, the object data properties, you can go generate rig. I will warn everyone about upgrading the face bone. You click on that, the bone faces change, everything seems to be fine, but as soon as you go to bind it, you're going to get an error. You have to go back and reattach some bones. I just don't bother. Just don't bother hitting the upgrade button unless they've fixed Blender 3.1. I haven't tried it yet. But yeah, generating a rig will automatically generate the bone control system that controls the actual, pig or a person. So you'll see that it automatically does it. You have your breastbones, you have your shoulder bones, you have all the main control bones, you have the eye control bones, the facial expression bones. All of that gets auto-generated for you, okay? And then you literally be turning off the bone rigs. Sorry, you turn off the armature and then just have that. Strongly recommend never delete anything, because as soon as you do it, like the meta rig here, you'll notice that it doesn't actually have any has normal purpose besides just being the position where the rig goes. That's all it is. So the meta rig generally gets turned off, and then that's it. That's the only time you ever use it. The good thing about leaving it in and not deleting it is if something happens to your rig, like you go to animate it and begin to realize one of your bones isn't moving properly, you just reset your animation, turn on the meta rig, delete the actual control bones, and then fix up your bone structure and then redo it again. Okay, it's pretty straightforward. So just sort of turn it off. You don't need to delete anything. All right, any questions before we sort of jump into this? No, we're all excited to do it.
Oh,
yes?
sorry, so where we can find this video then?
Pardon?
You recording this?
It's recording at the moment, yes.
So where will we find it?
I would believe I can share it on the ITE website, or I'll just upload it to YouTube and then I'll just email the link to everybody. So I'll stop the recording